welcome to another episode of Harrison Hobbies. Today we are going to be looking at the Goal Zero Sherpa 100 power bank. So this unit is, for all intents and purposes here, a pretty basic power bank. On the front here we've got the solar, so this is Goal Zero's proprietary plug. Lots of other power banks have it. We've also got some power delivery here. We've got some buttons and OLED display, and then we have some regular USB power, some Type A ports, and then the secret sauce here is its AC. So this one does 100 watts continuous. I have tested it and it goes quite a bit more than that sustained. So that's pretty awesome that it can do that. To manage heat, it's got a little fan in the back here. One last feature on here is it's got the Qi charging. So, if your phone has that, it'll do 5 watts out. My original use case for this was to bring camping. So my kids, they're 2 and 3 almost. And so you can keep them quiet and away from you if you give them tablets, for 30 minutes or an hour so you can have some sanity. So the intent of this was whenever we go camping, I've got a couple of Goal Zero power panels already. And so being able to have this out there and then charge 2 devices, their Kindles or iPads or phones or whatever, and then kind of keep them occupied with that. And then lastly, if we ever had a power outage and I don't want to have to bring out one of my generators, being able to run potentially a refrigerator, like a mini fridge. I don't think this will have enough oomph for a full size, or even power the TV so the kids can be entertained for that. The other really cool feature about this is the fact that it can charge with USB-C. That is actually, in fact, the primary way of charging it. Goal Zero doesn't even give you a barrel plug like they did with, I think, the Sherpa 50. That was the older last gen. And through the magic of Hollywood, we now have the original Goal Zero Sherpa 50. So this one is the base Goal Zero, and it has its sidecar here, the 50 or 75 watt, 100 watt peak inverter here. This one was actually a really cool design because you could actually remove this pretty easily, and it gave you just a stud as an output, so that with this, you could power this with a regular cigarette lighter, right? So this wasn't reliant on the actual inverter pack here, but it has that right there. And then they gave you the cable for it. So the fact that you could actually plug this in, and so now this can go into a cigarette lighter. And so you have yourself, for all intents and purposes, just a straight up AC to DC inverter that you could use with your car cigarette lighter. So that was really a cool feature. I think some of their bigger power tanks or whatever they call them also had cigarette lighters, so in theory you could use that. But it goes together relatively quickly. So just for a quick size comparison, the old versus new, in case you did buy this, because I know these were, for a long time, these were the only ones on the market that were, compact lithium DC to AC inverters like this. From a height, they're almost... this one's maybe double, but in terms of footprint, again, you have quite a bit more power on this one now. But, they're pretty similar in size whenever you look at like actual cube. The old one, again, did have the flashlight, and it had the 12 volt out and the laptop out. The laptop out, again, would never power anything like an Alienware. I think it had a max of 60 watts or something, and then it would trip. But again, both of these use the same panels. This is just this is the Nomad 13 folding panel here, not of particularly amazing quality. Even in direct sunlight, the most I've ever gotten out of this whenever I was using this here, because again, it'll show you your input state. I think I was getting like maybe 7 or 8 watts. And that's pretty typical for solar panels. Advertised is absolute ideal case. Maybe you're in Arizona very close to the sun. Here in the Pacific Northwest, there's always a little bit of overcast even on the brightest days, so we usually have some efficiency loss there. These are still going for around $300. They were a pretty cool feature, but now we've got so many others from like Anker and all the other companies that are USB-C rechargeable. They do the exact same thing, and we'll show why this is actually really overpriced for what it is here in a moment. So let's get in with some of the charge here, and so let's zoom in a tiny bit. So we start out here with the time to empty. If we press the power button again, that'll wake up the screen, so now it's full brightness. We can go through and we can turn on the Qi charging. We can turn on the AC, and then it shows you what's right there. And then we can also go through the menus. And so this right here is going to show what currently is drawing. We've got an HP Spectre Folio. So if we plug this into the side here and into one of our USB ports, we'll hit the power button again to wake up that screen. So we can see here that we're starting to get up to 12 watts. So this thing's probably fully charged. Just grab a cell phone, so maybe that'll be a little bit more stable. So we can see 3 watt out-ish sustained. So yeah, it shows you kind of what you're getting. And then if we plug one in, then we can see kind of the balance of in and out. So now we can see in here that we're pulling 16 watts out to the phone, and we're putting in right now off of that USB-C port here, 28 watts. One feature of this, I guess maybe a bug, would be the fact that, you know, on this here you have, both of these have roughly the same issue, and that's the fact that these are kind of software buttons, and so the machine is basically always on, and so you'll end up with a little bit of parasitic loss as a result of these. So again, this thing is down to 99%. I think whenever we started it was a 98, and I probably haven't used it for a couple of weeks, but it was at full charge whenever I put it away. So as a power bank, this thing is great, right? You know, it gives you lots of battery. This thing is... So it's a 94 watt hour and a 25,000 milliamp hour, right? So this will charge a regular phone, 5, 6, maybe 7 times. So it's got quite a bit of power. A couple of other cool features on this. These are super soft rubber inserts right here, and they are able to hold a couple of their USB cables. So in the event that you need to keep, you know, some cables to charge your devices on the unit itself. My wife is iPhone and I'm Android, so I mean we use A to Lightning, and then I use a C to C here. These come with it along with a couple of others, and so it's kind of nice that they're always with it in a very inconspicuous location here. It doesn't get in the way. So while yeah, this thing does have quite a bit of power, we'll move on to its major drawback, which for a $300 device, I was actually a little bit appalled by, is the fact that the waveform on the AC output is garbage. Standard setup is going to be a Hoover air purifier, just because it's got a little bit beefier of a motor. We're going to plug that into just a regular old power strip here, and then we'll get our O-scope plugged in as well. You guys are probably going to have to take my word for the current here. I mean, maybe the GoPro can get it, but we'll leave this here. And then we'll plug in the other end. Nice beefy heavy gauge extension cord so we don't have any losses here. We'll plug this in. So as we can see from the oscilloscope right here, we are in a proper square waveform. Our frequency, we're running 50, 65, 63 to 65 hertz. So that's a little bit high. And then we're seeing around 112 volts RMS. So again, we're a little under, right? We should be around 120 volts and 60 hertz. So right now, already the electronics in here are pretty much crap. So let's give it a load, right? And so this thing, again, you can see the little green light turned on. We're also powering this. We're pulling a little bit. So none of that should be, I mean, that should be in the realm of parasitic. So we'll turn on. And I don't know if you can hear that hum, but that is the motor being destroyed by this trash square waveform, right? And so if we go up to high, we are now pulling 4 amp. So 120, 240, 480? No. So the issue with that square waveform in an inductive load is anything that's basically like a motor. Capacitive loads are things like electronics. Those are fine with square wave because they basically take the signal, rectify it. They don't care what it looks like as long as it's the right frequency for timing purposes and then the correct voltage more or less, just so you don't start blowing stuff up because they do have a tolerance there. On inductive load though, you'll end up with a motor, right? And so you're going to end up with your stator, which is kind of that fixed part, and then your rotor. And so there are poles within the stator. And so whenever you have the AC signal, what you're supposed to do is kind of a ramp up One side pulls, the other side pushes in the stator, and it forces the rotor. Then the amplitude of that sine wave starts to increase, and it pushes it, kind of guides it through, and then as it gets to the next pole, then it decreases, and then it gently kind of tapers off, and then it goes through the next cycle. And so it kind of just ratchets its way through. The problem is whenever you get a square wave like this, like absolute trash, it doesn't have that nice transition. So it's like positive, negative, positive, negative. And so that's really, really rough on inductive loads. Something like this, would I trust putting my refrigerator on this? Probably not. But you know, this is, for all intents and purposes, a very, very trashy sine wave. Let's plug one more thing in just for fun. So we got a little Vornado fan here. Let's do the same thing. It says 0.35 amp, so what is 120 times 0.35? Gives us about 43 watts, right? So this is going to be 50%-ish of what this can output. So we will plug this into our strip here real quick. Okay, so we're on low, medium, high. Oh. There. And if you can hear that, I hope this microphone is sensitive enough. It is just whining. Let's compare that to what a load should sound like. Hear what that sounds like? Low, high, it's actually moving air, it's not whining. And so it sounds like whenever it's hooked up to this, it's actually skipping poles. So I think the key takeaway here is if you're considering buying one of these for AC power, you should really think again. Pretty much everything nowadays, I mean, GoPros, phones, computers, everything is charged by USB-C. The idea of having an outlet on one of these, it's becoming obsolete, right? I mean, nobody really needs an AC outlet anymore unless you're using like a gaming computer. But again, you know, this requires 160 watt. This does like 120, 130 at peak. You can't run anything on this. So, you know, if you're dead set on Goal Zero as a brand and you want to have the ability to put in solar, then I guess you're kind of stuck with this. If you are looking at buying just something to keep your other stuff charged, I mean, they make a $200 version of this that's basically the exact same without the AC, so they just lob off a little section of it. Certainly stay away from this. Don't spend $300 on this like I did. I was actually pretty late to the game in doing sine wave analysis. If I would have done this the day I got it, it would have gone back to the store, absolutely. To the folks at Goal Zero, for $300, I would expect better. I would expect a pure sine wave. You know, Xantrax, I mean, they're putting pure sine wave inverters in tiny, tiny packages. But hopefully this review helped somebody out. You know, it was a quick walkthrough. Think twice before you buy this. And thanks for watching, and check back soon for more videos.